So, as we were mentioning, it's getting close to the holidays, and so we thought we would talk about food. So today I'm going to talk about bread. So how many people here have eaten bread before? Most people, all people. How many people like bread? Do you like bread? Most people like bread. So we have to make bread, so we want to understand how we make this bread. So today we're going to talk about something very complicated title. It says the physics of leavening, right? So does anyone know what leavening means? It's a pretty complicated word. Maybe a new word for you. It means, how does bread rise? How does it go from very small and grow big? Right? So that's what we're going to learn about today. How does it grow big? So before I start, I'm going to tell you a bit about myself. I'm a computational chemist, so I do all my chemistry on the computer. And so this is actually something that I'm interested in personally. It doesn't have anything to do with my research, but that's why I think that's why I love science, is because it's everywhere. I get to study many different things and try to understand at the very small level. So that's what I'm trying to do today, is explain how everyday things like bread have to do with science and how you can enjoy science in every part of your life. So let's get on with the science. Okay, so bread rises. So here's a video that I want to show you. And if we watch carefully, this is an X-ray. So just like your luggage gets checked at the airport, we're looking at the bread over time, and you can see it's growing and growing and growing until the bread gets really big, right? So that's what has that dome top to it, right? And a lot of breads have that dome top, right? So the container keeps it in, and it grows really big, right? So that's how bread rises. So you may not have seen it in the oven. Maybe you have, but now you've seen it on the video. Has anyone made bread before? Have you tried making bread? Yeah, so not everyone has, so I'm going to take a second just to tell you about the basic way that we make bread. First, we take the ingredients, and we mix them all together and put them in a bowl, right? And that's the first step, is to just let it sit. So we're going to let it rise once. And so after a while, the dough will grow and grow and grow. And then the next step, sometimes we punch it back down and we can make it small again and let it rise. Other times we can just take the dough and put it in our tin and let it bake. So then we'll say we've let it rise, and then we're going to put it in the oven. And once we put it in the oven, it rises again, right? So once you put it in the oven, you can also watch through the window and see that the bread is growing. So today we're going to understand 2 times when it rises. First, when we let it sit and it just grows like a monster. And the second time when we put it in the oven and it gets really big. So now on to the science of bread. So bread is made up of a lot of things. And so we're going to break it down into some small pieces, right? So bread is about 41% starch. Starch is like the sugar. It has lots of sugar in it, so you might taste a little. It's sweet. Potatoes also have starch, so the taste of potato is mostly starch. We also have protein. So protein doesn't just come in meat. You can get protein in other places too. Like we'll learn about the protein today in bread. There's also fiber, and there's also fat. And then there are other things that we don't consider to be any one of these 4. But today what we're going to talk about are 2 things. We're going to talk about protein, and then we'll also talk about yeast. And so that falls into the other category. So let's start with the protein. The protein in bread is something we call gluten. And in reality, gluten is actually 2 things. Gluten is made up of one type of protein called glutenin and another type of protein called gliadin. So glutenin is long and it's stringy like noodles, and gliadin are more compact. And what happens is the gliadin and the glutenin, they're looking for each other. And if gliadin finds a part of glutenin that it gets along with, it's going to connect to it and not let go. So what happens is, as we knead the dough and we're pushing it around, we're helping the gliadin find the glutenin, and you make this network. So when we knead it, we put it together, and we form this network. And what happens is we make these pockets. So glutenin and gliadin make these bubbles. And so we have a little pocket here that's just full of gas or air. And then we also have another pocket here, for example. right? And so the dough has full of holes, full of pockets. And so that's an important part of bread making, is to make these holes. So the longer you knead, the more networking that you can get between these two proteins to form the gluten. And this is what we call the gluten. All right, so that's the protein. And now I want to talk about yeast. So yeast is a small cell. So if we zoom in on the yeast, we can see that they're small little cells. And so they have a very important role in making bread. When yeast is surrounded by things that it needs, like you need food and you need water, right? It performs its duty. It does its role. And so it takes sugar and oxygen. And if we feed yeast, what happens is it says, well, I want to make more yeast. And so the population of the yeast grows and grows. And in addition, these yeast create a little bit of bubbles, and that's carbon dioxide. Right? So that's the gas that we see in bread. Right? But as the yeast are consuming the oxygen, and they're taking in the oxygen levels go down and down and down. So eventually, there's going to be very little oxygen left. So the yeast then have to say, okay, we have to do something else. There's no more oxygen left. So we're going to do a different task. We don't want to make more yeast. We just want to create carbon dioxide, or the gas. So what happens now is that we generate a lot of carbon dioxide gas. So when the bread rises, it gets really big because there's very little oxygen in the dough left. And so then the dough grows very quickly. And we call that process fermentation. And fermentation has other products too. But we're really concerned about the carbon dioxide, because that's what leads to the growing of the dough. So here's an example of the dough before and after we let it rise. Here we have a very small amount of dough, lots of pockets. Can you see the pockets? Can you see? And then we let it rise, and it gets really big, and the pockets get really big because they're now filled with carbon dioxide, the gas that the yeast creates. So let's pretend that this grid is like those pockets. The white lines represent the gluten. It makes these bubbles in these pockets. And we're going to take the yeast that we saw before, and they can be in any one of these pockets. So we see them all over the place in the dough. And so we let the dough rise, and what happens is after a certain amount of time, we start seeing that all of these pockets get filled with carbon dioxide, and that bread dough gets much larger. Does that make sense? So the yeast is what causes the dough to grow. But you should have a question, because yeast stops working above 120 degrees Fahrenheit. So does anyone know the temperature you might bake bread at? Maybe 350. It depends what type of bread. We'll say 350. 350. Is 350 higher or lower than 120? 350 is, anyone? It's higher. Yeah, so 350 is higher. So do you think that the yeast is working? No. So why does bread grow in the oven? And that's the next part. So we had the biological reason, and the bread grows because the yeast is producing gas. But now the yeast isn't working, so what's the reason? That's what we're going to talk about now. Does anyone recognize this?
Molecule.
It's a molecule. Does anyone? So a molecule are very small components. You might have heard of oxygen or hydrogen, for example. Those are atoms, and atoms make up a molecule. Does anyone know what this is? There's one oxygen and two hydrogens. H2O. Does that sound familiar? Water. So this is water. So I'm sure you also all drink water. Water is the reason why bread grows the second time in the oven. This is water vapor. So we have another image of the bread dough. Here, the black dots are the pockets in the gluten, and the gray is the gluten itself. And this is done using the same technology that you might get at the hospital. This is called a CT scan. So again, let's think about our network of gluten and our pockets. And now, instead of yeast being in the cells, we're going to put water in the cells. So each of these pockets has water. So let's take a look at one of the pockets up here, right? And we'll zoom in. And what we see is it's actually not one water. It's a lot of water in this pocket. So at room temperature, so the temperature right now, you can feel on your skin, this is room temperature. The water is moving, but it's moving a little slowly, right? So it's going about the cell and it's bouncing off and moving around, right? Okay, we're going to put the cell, the dough, into the oven. And 350 degrees. Is it higher or lower than room temperature? Higher, yeah. So when we raise the temperature now to the baking temperature, does anyone have any guesses what might happen to the water? Is it going to move? Yeah. Why do you think it's going to move slower? So you know about evaporation. Does everyone? That's a very complicated word. Yeah. So in the water, it's very similar to the water cycle, right? So if there's a certain amount of temperature or energy that you're giving to the water, then the water molecules are going to move faster. And so in this case, we're going to look at the movement of the water, and we see that it's going to move faster. So in this case, when we put it in the oven, the water will move faster. And when you're moving faster, you're pushing harder, and so those pockets are going to grow, just like the yeast was creating the new gas that was pushing on the walls and making it grow. So now we understand the physics of leavening. So when you put it in the oven, it's the expansion or the sudden growth of the cells because the water molecules, the water vapor have a lot more energy. And so we saw that first video I showed you of when the dough confined in the tin and we saw it grow over the top. So we'll put the dough in and we allow it to grow, and it can only grow up in the direction because it can't go through the tin walls, and we form our nice dough. So I'm all done. We've learned about gluten. That's the protein. We learned about the pockets and the yeast that generates the gas, and the gas in this case is carbon dioxide. And this is what leads to the first rising. Now we also learned about water vapor, and that's the reason for the second rising. Right? So hopefully you can understand, and you can go when you're making bread or you see bread in the store, you can tell your friends or your family, you know why it's as airy as it is. And so what I'm going to do now is while I take questions, I'm going to show you a sample of the dough that I made earlier. Now some of these have yeast, and some of these do not have yeast. So you'll see that some are a bit fluffier, and others are not. So in this case, we're only going to look at the dough after the yeast is being used. I didn't bake this yet, so if we put it in the oven, you would see it grow again with the water. So right now, we're just looking at how yeast works. So I'll pass this around, and you can look and you can poke at it, and you can guess which ones have yeast and which ones do not have yeast. But with that, I'll be more than happy to answer your questions about bread rising. That's a very good question. So let's talk about the water. We'll start with the water. So when we put the water in the oven, we raise its temperature, right? And the energy in the oven is going to cause the water to move faster, right? So imagine there's a wall, right? And I'm going to walk towards the wall, and I'm going to push the wall. Do you think I'll move the wall? Probably not, right? Now I'm going to take a running start, and I'm going to run towards the wall. Is it more likely I'm going to move the wall? Could I move the wall? No. Maybe. So we might think of that table, for example. Or if I move towards the table, am I going to move the table? If I run towards the table and push it, do you think I'll move it? So the more energy you have, the more likely you're going to move those walls. So when we put it in the oven, the water has enough energy to push the bread out and make it grow. So that's the answer to why water helps things. That's a very good question. Why does bread turn brown? So what do you think happens when you had mentioned the water cycle, right? So what happens to water in the water cycle when it evaporates? It
goes into a cloud.
Goes away. So there's not a lot of water in bread, but the water can leave the bread as well. So when you toast it and you're putting more energy, the water's going away. And then what happens is the water can't protect the bread anymore, and the bread starts breaking down. And so just like you could set fire to something with heat, it's sort of like you're setting fire to the bread very slowly. Right? So that's why it gets crispy. And sometimes if you put it in the oven for too long, the toaster for too long, it could turn black. Just like in a fire, you have all the ash, which is black. All right. Thank you very much.